Okay, students, we're going to keep going with this. I want to talk about the difference between ionic bonding and covalent bonding. So ionic bonds, we've talked about before, is formed when one or more valence electrons is transferred. Or is it are transferred when it's one or more? I don't know. You can ask your English teacher whether it's is transferred or are transferred. From one atom to another. Formed when one or more valence electrons is transferred from one atom to another. So sodium has one valence electron, and I'm going to mark it with an X because I want to keep track of it different than the chlorine. Chlorine has 7 because it's in column 17. Okay, and when they come together, this sodium's like, I've got this electron, and my ionization energy is low. The cost to remove this electron is low. And chlorine says, I like electrons. My electron affinity is high. The amount of energy I'm willing to pay to get an electron is high. So they make the exchange, and sodium loses its electrons, becoming sodium plus, and now chlorine has all 8 electrons, becoming chlorine minus. So there's a complete transfer. And now those sodium and chlorine ions can separate from one another while leaving the electron that originally belonged to the sodium belonging to the chlorine now. That's ionic bonding. And that's why we learned this thing about like a +1 charge, a +2 charge, or a -1 charge for the columns, because that was like how many electrons they were willing to lose or willing to gain to form an ionic bond. In covalent bonding, it involves the sharing of electrons. Involves the sharing of electrons between atoms. Involves the sharing of electrons between atoms. So you got these 2 chlorine atoms. They both have 7 electrons. And then they come together, and they both kind of want to have this perception of having 8 electrons. But if one of them gave it up, that would have 6, and that would be bad. So instead they put the 2 electrons that they both want in between them, and they share them. And you will see as we move on in Lewis structures, we will put those shared electrons as a line. So a line represents a shared pair of electrons. A shared pair of electrons between those 2 chlorine atoms. That's what that means. Okay, so go ahead and turn the page. Electronegativity, I'm going to write down the definition, and then we're going to use it more later, is the ability of an atom in a molecule. So now we're in a covalent bond situation, to attract electrons to itself. So this one was mentioned on your periodic trends, Pogel, and it has the same trend that we've been noticing in ionization energy and electron affinity. But these guys in column 18, they don't really have electronegativity because you have to be in a bond to have electronegativity. So column 18 doesn't really participate in bonds, but otherwise it's high up here with fluorine being the highest and low down here with francium being the lowest. The ability to attract electron while being in a covalent bond. So fluorine will be the most attractive. And then we're going to turn the page, and we're going to actually drop down here to what is a chemical bond. We're going to skip this bit about lattice energy for now, for this year. So what is a chemical bond? A chemical bond is the sharing of a pair or pairs. Oops, I wrote of and meant or pairs of electrons between two atoms. And why do chemical bonds occur? The chemical bonds occur because it is the lowest energy state for two atoms or a group of atoms. So two atoms come close to each other and they're like, I wonder what's going to happen. So when they're far apart, they're not attracted to each other at all. When they're far apart, they're not attracted to each other at all. So if we were graphing like the potential energy, when two atoms were very far apart, so this is a distance over here, distance on this axis. When they're very far apart, they don't even recognize each other. So there's no attraction, no repulsion. Attraction is graphed up here. Nope. Attraction is graphed down here. So sorry. And repulsion up here. Okay, so when they're far apart, they don't notice each other. But then as they come closer together, they start to feel more attraction than repulsion, because the one nucleus is like, I like those electrons on that other atom. And the other nucleus is like, I like those electrons on that atom. So they start to feel some sort of sense of attraction. And then there's a point where the attraction is maximum compared to the repulsion. But then as they get too close together, those nuclei, if the nuclei start to touch, there is way too much repulsion and they push each other apart again. So what happens is, this is representing the bond. This is the bond. And it's the lowest energy state that those two atoms can be in at a specific distance from each other that makes it maximize the attraction between them. And then because that's the lowest energy state, they want to be that close together that it requires energy to separate them or push them closer together. We call that the bond, because they're going to kind of stay in that spot. It's like being at the bottom when a ball rolls down a hill. At the bottom of the whole hill is the spot where it's going to stay unless you push it out. So that's why chemical bonds form. And tomorrow we'll get into Lewis structures.